Okay, today I'm going to talk about standard form, but first I'm going to review a couple of forms that we've already had. So SI, that's short for slope-intercept, y equals mx plus b. All of the equations for a line have a y and an x, and those represent all the points that are on the line. So if I pick up any point off a line, I'll be able to put them in for y and x, and this will be true. The m and the b are constants. In this case, m is a particular constant. That's the slope of the line. And b is the y-intercept. And if you look at websites that are based around the world, I know in Europe, they usually put a c there. I don't know why we put a b or why they put a c. We just have a constant there at the end. We also have point-slope form. So we have y minus y1 equals m times x minus x1. And you can see the same idea. You have a y and an x and an equal sign. But we have different constants here. I have the y1 and the x1, and that represents any point on the line I can plug in there. So for x and for y, the x1 and the y1, I can put in any point from the line, and then this will work. And then the slope is still m here. So standard form is going to kind of follow those same conventions. ax plus by equals c. For some reason in standard form, we write a, b, and c with capital letters. Again, I don't know why. This is just the form that we use. Actually, standard form, when you have equations with higher exponents on the x and the y, other than 1, we have curves and all kinds of crazy stuff. Standard form is the only form that survives. Slope-intercept and point-slope forms both go to the side at that point. So this is the form that kind of will be more useful in the future. But the constants don't tell us as much. Just a, b, and c. If you have any of those by themselves, that doesn't really tell you too much about the line. Okay, and one thing that I do want to note here, though, is that A, B, and C, A, B, and C are usually integers. A, B, and C are usually integers. And one way that I could write that in fancy math talk is to say A, B, C are elements, a little sideways E, of Z. I will not require you to use or know this notation. I just want you to see it once for now, so that when you see it in the future and other teachers will make you know it, then you'll be like, oh, okay, I've seen that before. That kind of looks familiar. So the Z means the integers. This is saying A, B, and C are elements of, belong to, the integers. That's all I'm saying there. And again, this is not something I'm going to test or require you to know. I'm just throwing it in there because it'll make you seem really super smart. When you do learn that, and you're like, oh, yeah, I've seen that before. Easy stuff. Not really easy, but when you say that, people think, oh, you're smart. Okay, let's graph. So 3x plus 2y equals 6. So you can see I put in constants for a, b, and c. And to do this, I'm going to take the 3x and the 2y and set them both aside. I'm going to say they both equal 6. What I've really done is I've put in zeros. So if you put in 0 for y, this term disappears and I get 3x equals 6. And if I put in 0 for x, this will go away. And this is left over. But I'm not terribly worried about that at the moment. So let's divide by 3 here. These are easy peasy to solve. X equals 2. Divide by 2 here. Y equals 3. So once you have this, it is super, super easy to graph. Let me draw this and this. On the x-axis, go to 2 and put a point. On the y-axis, go to 3 and put a point. And then draw a line. A line through those points, and that's it. That's all you need to do. Okay? So I want you to try one of these. Try it, and I'll give you the equation 4x minus 2y equals 10. 4x minus 2y equals 10. Go ahead and try that out using a similar technique. One of the numbers will be a decimal. Go with it.